more differentiating. So we did all this business with the derivative, and we played around with this definition of the derivative. And after that, we used this problem, and we said the reason that we had a derivative was to allow us to find the slope of the tangent line. So looking at this problem number 1 we did, in blue and green and black here, these are the things that we're going to try to use to find our derivative, come up with the slope of the tangent line as having 1 point. Well, what we're going to work on now is we're going to use this alternative form of the definition of the derivative. And this alternative form streamlines the process a little bit. So what it will allow us to do is it will allow us to jump straight to finding the slope of the tangent line at whatever specific x value that we want without using this definition of the derivative and all these x's and h's and all these crazy things. So what it's going to allow us to do is a problem like number 2 right here in one step without having to find the derivative and then plug an x value in. So how do we do that? Alternative form definition of the derivative. This will give us the derivative value at a specific x. So it'll give us a specific derivative. So f prime of c. So this c right here is a specific x value. Like 4, for example. Well, how do I go about figuring this out? Well, limit as x approaches then whatever that x value is of the function itself minus the function with that x value plugged in all over x minus that specific x value. So this is the alternative form of the definition of the derivative, this f prime of c thing. It's going to give us the derivative at a specific point. So again, I'm going to contrast this with problem number 1 up here. I'll come back and do that in a second. Actually, maybe I'll leave it so you can see it. Find the equation of the tangent line to this function at the point 1, 5. So our c value that we're talking about is 1. Use the alternative form of the definition of the derivative. So let's write that part down first. And again, I'm going to make this a little bit, I'll give myself some more room to work here so that I can kind of see it. So I'm going to start out by writing down what that alternative form of the definition derivative is. F prime of c is equal to the limit as x approaches c of the function itself, f of x, minus f of c, all over the difference between x and c. So there's your alternative form. Now, how do we go and use this thing? So the way that we do that, so in this case, the c value that we want is 1. So we're looking for f prime of 1. And what this is going to do, instead of, like above, having to find this red thing, this thing in this red box, 1 over 2 root x, and then plug a specific x value into it, we're going to have this by the time we're done simplifying this limit. So limit as x approaches 1 of f of x. Well, what's f of x? F of x is 3x squared plus 2 minus f of 1 all over x minus 1. So, well, what is f of 1? F of 1, let's see. So f of 1, oh, wait a minute. F of 1 is right there. So I'm going to put a big old 5 in the place of that f of 1. And now, once I simplify this limit, I'm going to have what I need. So limit as x approaches 1 of 3x squared. What's that going to be? How about a minus 3 in the numerator, all over x minus 1. And by the way, the thing you're going to find out with this alternative form of the definition of the derivative, because you're taking the limit as x approaches c and there's a quantity x minus c on the bottom, your direct substitution will never work with this. So you're always going to have to play around with it. What are we going to do here? Well, I'm kind of feeling like let's take out a 3 and let's factor this to x plus 1 and x minus 1. We'll have difference of 2 squares. And now my x minus 1s will drop. Once my x minus 1s drop, my direct substitution will work. What am I going to end up with? I think I'm going to end up with 3 times 2, or 6, by my direct substitution. And that 6 represents my value of the derivative at x equals 1. Now, again, this is a lot quicker process. Let's make this smaller again. This is a lot quicker process than it was above. When you look at what we did above, we had to find out what the derivative was and then plug in our x value. Down here, we didn't find what the specific expression was for the derivative. We found what the specific slope is at x equals 1. So the above method, the definition of the derivative, gives you an expression that you can put any x value into. So once you got that expression, it's very versatile. Problem 2, if you wanted to do this now, let's say, for example, let's say I wanted to find f prime of 7, I'd have to repeat all of this crazy stuff. I'd have to do it all again in order for that to happen. Now I'm going to erase this. In order to find out what f prime of 7 is, I'd have to do it again. So it's not as versatile. It's quicker for one specific x value, but it's not as versatile if you need multiple ones. And that's alternative form definition of the derivative.